Hello everyone, welcome to Stuti Academy. I'm Poonam Sharma, your science teacher. Welcome you all another session of atoms and molecules. So children, in previous class I started with this new chapter, atoms and molecules, which is chapter number 3 of chemistry of class 9. So in previous class I've discussed about few laws which were given by Lavoisier and Joseph L. Proust. They are known as the master of chemistry because they have given such an important law of chemical combination. First law which was given by them was law of conservation of mass, which I have already discussed with you. Like mass can neither be created nor be destroyed in a chemical reaction. So for proving this law, I have taken few examples of like calcium carbonate. When it reacts, it decomposes. It results in the formation of calcium oxide and carbon dioxide. So, and if we look at the mass of reactant and product, they both are equal. Another example which I have taken for this law conservation of mass was log and fire. When we burn piece of wood, then it results in the formation of ashes and smoke. And then if we compare masses of reactant and product, then also it remains same. Another example in which physical changes are involved. In other two changes, chemical changes were there. But here it is a physical change, and in physical change also, the mass of reactant is equal to mass of product. So it is always like this. Whenever any chemical reaction takes place, mass of reactant is always equivalent to mass of product. So these examples we have already discussed in previous class. And law of constant proportion also I have discussed with you, in which like it states that in a chemical substance, the elements are always present in a definite proportion by mass. For example, water. If you take an example of water, which is a combination of hydrogen and oxygen. So this water, if it exists in any form, whether it is solid, liquid or gas, or you can take a sample of water from anywhere, whether it is a sample of sand, from ponds, lakes, rivers. So everywhere the ratio of mass of oxygen and water is always 1:8. So this is according to law of constant proportion. And with the help of this example, it is very much clear that as you can see in all the reactions, when carbon dioxide gas is released, so the combination, the masses of carbon dioxide gas in each reaction is equal. So it is 3:8 only. This law, these are the examples which proves the law of constant composition. Now, but there are some limitations of law of constant proportion. Because the limitations of this law is restricted to isotopic elements, so which have same atomic mass but different atomic number, and it is not applicable to those who have two or more compounds. If two or more compounds form the same element, for example, alcohol and dimethyl ether. So these examples I have already discussed with you in previous class, and I hope you have gone through all these topics. Gay-Lussac law of combining volumes also we have discussed in previous class, which states that at the same temperature and pressure, the ratio of volumes of reacting gases are small whole numbers. And for proving this, here is an example: 2 volumes of hydrogen, and when combined with 1 volume of oxygen, it results in 2 volumes of water, which is in the gaseous form. Now, these laws, whether it is law of this conservation of mass or law of constant proportion, these laws were lacked in some cases. So, to overcome those limitations, Dalton proposed his theory, which is known as Dalton's atomic theory, or we call it DAT. This is Dalton's atomic theory. In his theory, he explained those limitations, those drawbacks which were there in the previous laws. According to his theory, there are some postulates, like every matter is made up of very tiny particles, called atoms. These are so small that we cannot divide them, or we cannot create or destroy in a chemical reaction. And all atoms of given element are same in size, mass, and chemical properties. Like atoms of different elements are different in size, mass, and chemical properties. Atoms combine in the ratio of small whole number to form compounds. The relative number and kind of atoms are constant in a given compound. So these points I have already discussed with you in previous class. These are the postulates given by Dalton. But there are some drawbacks in his theory also. So when these laws were used in isotopes or isobars, his theory failed there. So that's why there were some drawbacks in Dalton's atomic theory also when it's a matter of isotopes and isobar. So these are the drawbacks of Dalton's atomic theory. Now, what kind of question can be asked in exam on the basis of these topics? First, I'll discuss those question answers with you, which are extremely important according to exam point of view. So, first question is just in front of you, like carbon dioxide gas produced by action of dilute hydrochloric acid and potassium hydrogen carbonate is moist, whereas that produced by heating potassium hydrogen carbonate is dry. What would be the difference in the composition of carbon dioxide in the two cases, and state the associated law? They are saying if we react dilute hydrochloric acid with potassium hydrogen carbonate, and if we are heating potassium hydrogen carbonate, so if we are treating potassium hydrogen carbonate in a dry form with dilute hydrochloric acid or in a moist form with dilute hydrochloric acid, in both the cases carbon dioxide gases evolve. They are asking what is the difference in the composition of that carbon dioxide gas in these two cases, and which law is associated with it. So if carbon dioxide gas is released in both the cases, the ratio is always 1:2. And this law associated with the law of constant proportion. If you remember, I have given an example of water. So water, whether it exists in solid, liquid or gaseous form, its composition remains same. It is always constant by mass. So similar case here also. So whether carbon dioxide gas is released in any of the case, it always result in the formation. It will always result in the same proportion by masses. So law of constant proportion is associated with this property. Now next is give an example to show law of conservation of mass applies to physical changes also. In previous examples which I have discussed with you, I have given 2 or 3 examples. Out of those 3 examples, one was with physical changes, in which we have taken an example of melting of ice. Melting of ice is a physical change, because here only there is a change in the state, so there are no new substances formed, so that's where it's a physical change. So when melting of ice takes place, it results in the formation of water. But the mass of water, which is H2O, it is same. Like whether if suppose ice is 30, and if you get water, it is also 30. Although state is changed, but the masses remain same. So this law states that conservation of mass. So mass can be conserved. It cannot be destroyed or created. So whatever mass we have taken in case of reactants, suppose it is 30 kg. Here also it is 30 kg. So this example verifies the law of conservation of mass. Now next question is, Dalton's atomic theory is contradicted by the formula of sucrose justifies the statement. According to Dalton's atomic theory, whenever atoms are present in an element or when they combine in a simple whole number ratio. But this formula, if you see this formula, it is made up of carbon, hydrogen and oxygen. They are not combined in a simple whole number ratio. This ratio is not simple. So that's why this formula of sucrose is contradicted Dalton's atomic theory. So these kind of questions can come in exam. Apart from this, state the postulates of Dalton theory. It is extremely important question, and generally this question comes in 3 marks. So in this question you need to write all the postulates of Dalton atomic theory, which we have discussed, like all matter is made up of very tiny particles, atoms are indivisible, which cannot be created or destroyed, atoms of a given element are identical in mass and chemical properties, atoms of different elements have different masses and chemical properties. Atoms combine in the ratio of small whole numbers to form compounds. And the relative number and kind of atoms are constant in a given compound. So in this you need to write all the postulates of Dalton. And it is extremely important question. According to exam point of view, generally it comes in 3 marks. So learn all the postulates by heart. Apart from this, sometime one more question can be asked in exam. Write the limitations. Limitations of Dalton's atomic theory. So in that also you have to write those limitations which I have already discussed with you. So these are extremely important questions. Now let's move on to atoms. Atoms, as we know, that these are the smallest particle of an element, and these atoms which are a part of an element, they take part in a chemical reaction. Like for example, we have hydrogen. This hydrogen is made up of so many atoms, but they all are similar in their properties. They belong to the same property of this hydrogen, and size of atom is extremely small. This atom is extremely small, so we cannot measure in any particular unit like meters, centimeters. So we need special unit for it, and that is nanometer. So size of atom measured in nanometer, and 1 nanometer is equal to 1 meter. So 10 raised to power 9 nanometer is equal to 1 meter. And atomic radii of hydrogen is 1 into 10 raised to power minus 10 meter. So this is the size, this is how we measure size of an atom. Then there are some symbols of atoms which were given by Dalton, and these are the symbols which were proposed by him. But it is very difficult to write those symbols every time when we are writing chemical reactions. So that's why later modern symbols came into existence, which were given by Berzelius. And these are the symbols, and these are name of elements. So these symbols we have already discussed in previous class, and generally whenever we are giving any symbol to a particular element, we use first letter of the element, and symbol first letter is always capital. And sometimes we use a Latin name because so many elements start with the same alphabet, so it creates confusion. So to avoid that confusion, some elements are named or given symbols on the basis of their Latin name, or some elements are represented by symbols with their first or third letters, and first letter is always capital. As you can see, these all starts with C. Carbon represents by C, copper by its Latin name cupra, cobalt CO, first 2 letters, chlorine Ca, cadmium Cd. So as you can see, there are n number of elements which start with same alphabet. So that's why we have chosen different rules or different ideas for providing some symbols to them. Now, what is the significance of symbol? Why there is a need to give symbol? Symbol basically stands for the name of the element. because every time we cannot write name of the element when we are writing chemical reaction. It is a very time taking process, and that's why symbols are very important. And symbol stands for one atom of the element. Suppose O, so it stands for one atom of the element. Symbol also represent the quantity of element equal in mass to its atomic masses or gram atomic mass. What are these atomic masses and gram atomic mass? We'll discuss later. Symbol also represent mass of element which contains one Avogadro's number of atoms of that element. So symbol, for example, O stands for element O, one atom of oxygen and mass of oxygen equal to gram atomic mass. It means 60 gram of oxygen, because oxygen always exists as O2 and its atomic mass is 16. So mass of oxygen which contains one Avogadro number of oxygen atom. This is Avogadro. Then we have molecule. Molecule is the smallest particle of an element or a compound. Why we are using this term smallest particle of an element? Because H2O, so it's a compound. And if we are talking about this molecule, so this is completely a molecule. When hydrogen, two hydrogen combines with one oxygen, it results in the formation of water. So here, two elements, these are the elements. It means this molecule stands like one molecule of water, but which is a combination of two atoms of hydrogen and one of oxygen. So, and the molecules exist independently. Now, molecules of an element constitute the same type of atoms. Suppose here it is a combination of two hydrogen, and the atoms of this hydrogen and this hydrogen are same. Molecules may be monoatomic. If it contains one atom, it is monoatomic. It contains two atoms, diatomic. It contains more than two, it is known as polyatomic. And molecules of compounds, when they join together in definite proportion and constitute a different type of atom. Now let's see examples. Number of atoms present in a molecule is known as its atomicity. For example, if we take an example of helium, which is an inert gas, so it exists independently and it is monoatomic. As you can see, here is only one atom of helium is present. If we talk about neon, it also contains one. And till here, argon, sodium, iron, aluminium, they all are monoatomic. They contain only one atom. Now, let's come to hydrogen, oxygen, chlorine, nitrogen. They contain two, so they are diatomic. Phosphorus contains 4, so it is polyatomic. Sulfur contains 8, so it is also polyatomic. So the number of atoms present in a molecule is known as its atomicity. Now how these two, N2 and 2N, sometimes we write like this and sometimes we write like this. How they are different from each other? As you can see here, in N2 and 2N, these are the two different forms. Now if you look at this example, N2. So basically the difference between this N2 and 2N is, this N2 is a molecular nitrogen or nitrogen gas, and this 2N contains two atoms of nitrogen. So if we talk about molecular formula, so it is this. It contains two atoms of nitrogen, and here it is two molecules. So this 2N represent two atoms of nitrogen. As you can see here, these are two atoms. And this N2 is a molecular nitrogen. As you can see here, it is diatomic and it exists in gaseous form. And this exists as a free nitrogen atom. So this N2 is inert while 2N is highly reactive. So if we take an example of this, how they are two different from each other. So with the help of this diagram, I think it is clear to you. So N2 represents molecule of nitrogen, and 2N represents atoms. Rather, I can write two atoms of nitrogen. So I hope from this example it is clear to you how atoms are different from molecules. And if we say thus N2 is the molecular formula of nitrogen, this is not the molecular formula because it contains two atoms of nitrogen. Now there are molecules of some compounds. Let's take an example of water, which is a combination of hydrogen and oxygen. And hydrogen and oxygen present in ratio by 1:8. So whether these compounds exist in any form in nature, this ratio always remains constant. And let's take another example of ammonia. It is a combination of nitrogen and hydrogen. So ratio by mass is 14:3. Now comes to carbon dioxide, and it is 3:8 ratio. Glucose, which is a combination of carbon, hydrogen and oxygen. So 6:8. Now we have common salt, which is sodium chloride, 35.5. It is 35.5. It is not 3.5. And if we take an example of HCl, which is a combination of hydrogen and chlorine. So it has ratio 1:35.5. And now let's take another example of methane gas, which is CH4, which is methane gas, which is a combination of carbon and hydrogen. Now in this, the ratio is 3:1. So these are the ratio by masses of these elements which are present in these compounds. Now how atoms are different from molecules. If you look this example of oxygen and water, atom of oxygen, it is made up of protons, electrons and neutrons. Pen. So these three things are present in atom. And if we look at the molecule here is water, which is a combination of hydrogen, two hydrogen atoms and one oxygen atom. So if we take this individual one, so this is atom. Hydrogen is atom and oxygen is atom, which is a combination of, this water is a combination of two hydrogen atoms and one oxygen atom. So this is how atom is different from molecule. And what are the other differences between them? How can you differentiate atoms with molecules? As I told you, atom is the smallest particle of an element that takes part in a chemical reaction. And molecule is the smallest particle of an element or a compound that is capable of independent existence. As you can see here, this water is independently exist in nature. But it's not, this oxygen cannot independently exist in nature. It can react with another oxygen atom so to make it more comfortable. Except inert gases, inert elements, other react with some other one to make them stable in nature. An atom is usually not stable by itself. Just now I told you, if we talk about oxygen, oxygen cannot exist as O in nature. either it combines with another oxygen which results in the formation of O2, or it combines with two more atoms of oxygen which results in the formation of O3, which is ozone. This ozone layer is present in our atmosphere which protects us from harmful UV radiations. But if we talk about molecules, they are stable by itself. For example, CO2, it is stable in nature. H2O, HCl, anything, any example you can take, they all exist independently in nature. Now let's see another example. Another difference between atoms and molecules. When similar atoms combine together in varying numbers, molecules of different properties can be formed. Like the property of this oxygen and ozone are entirely different. When two atoms of oxygen combine together, it forms oxygen. And when three atoms of oxygen combine together, it forms ozone. And the property of ozone is entirely different from that of the ozone. But in case of molecules, when similar molecules combine together in any number, a simple similar product is obtained. For example, if this water is present in solid form, or if it's present in liquid form, or if it's present in gaseous form, in all the three forms, one is ice, water, and then water vapors. In all the three forms, the composition of water remains as it is, and its property also remains as it is. Fine. So similar product is obtained, and we have taken example of carbon dioxide gas also. So whenever carbon dioxide gas is evolved in any of the reactions, the composition remains same. So these are the differences between atoms and molecules. So I hope till here atoms and molecules are very much clear to you how they are different from each other. Now next is atomic mass of an element. We are talking about atoms every time. So but these atoms have some atomic masses also. They are extremely small. We cannot measure them in grams or kilograms. So we measure them by certain unit that is known as atomic mass unit. Atomic mass unit, or we call it AMU, or you can represent by U. So if we want to measure the atomic mass of an element, these atoms are extremely small and the actual masses of elements are so small. So it is difficult. So that's why we need to measure the atomic mass of individual atoms. So how can we measure? There is a unit, we call it atomic mass unit or AMU. So now for atomic mass unit, it is compared with the isotope of carbon, which is C12. As we know, carbon exists in nature in carbon 14, carbon 12 form. There are isotopes of carbon, they exist in different forms. But the most appropriate which we are using for relating it with the atomic mass is carbon 12. Now the question arises, why we are not using any other elements? Why we have taken only carbon if we compare it with the atomic mass unit? Because when although it was the work was done on other elements as well, but when the relation was taken between the atomic mass of an element and the other element, so they have given answer in points or in decimal. So it is very difficult according to this numerical point of view. But if they have taken carbon 12, so it gives the appropriate number. So that's why carbon 12 was taken as a reference for measuring atomic masses. So whenever we want to measure a mass of any element, we always take the reference of carbon 12. For example, and before that, relative atomic mass is mass of one atom of the element upon mass of 1/12 of an atom of carbon 12. What does it mean? See, carbon, this is the carbon. It means carbon 12 means we are separating this carbon into 12 parts. When we separate carbon into 12 parts like this one portion, one out of 12, one portion is equal to the 1 AMU. So that's why it is taken as a reference. And it is more clear by this example. One atom of oxygen is 16 times heavier than 1/12 of an atom of carbon 2. So whenever we are comparing atomic masses, so we always take carbon 12 as a reference, 1/12 times. So here we can say that one atom of oxygen is 16 times heavier than 1/12 of an atom of carbon 12. So this is taken as a reference one. And relative mass we express in ratio form. That's why it does not have any unit. But atomic mass unit is AMU. Remember it? It is atomic mass unit. So how can we define this atomic mass unit? It is defined as 1/12 of the mass of an atom of carbon 12 isotope on the atomic scale. Whatever mass of the atom is there, it is always heavier than 1/12 of the carbon. So we can write like this: 1 AMU is equal to 1/12 into 12 upon 6.023 into 10 raised to power 23, which is Avogadro's number, and we will get this. So 1 AMU is equal to this mass, and generally this is equivalent to mass of whether proton or neutron. It is equivalent to proton or neutron. So 1 AMU, 1 atomic mass, is equal to this much of kg. So just remember this one. Now gram atomic mass. How can we represent it? It is a quantity in grams. When we measure atomic mass in grams, which is numerically equal to the atomic mass of an element. And for example, here I have written 1 gram atom of hydrogen, which is equivalent to this one. And 1 gram of sodium is equivalent to 23 grams. So relationship between gram atoms mass and atomic mass of a substance is given by this formula. Number of gram atoms is equal to mass in grams upon gram atomic mass. Or relative atomic mass is represented by mass of one atom upon 1/12 of the mass of an atom of carbon 2. So for example, 16 gram is the mass of oxygen. So we can say that oxygen is 16 times heavier than carbon 12. So this we have already discussed. Now here comes atomic numbers, elements, their symbols and atomic mass numbers or the mass numbers. Now first of all you need to learn these atomic numbers at least till 20. So learn all these atomic numbers, it is very important. Now first is hydrogen, whose atomic number is 1 and it is represented by symbol H. And the atomic mass is 1. Now these are the atomic masses of different elements. And here we have helium, whose atomic mass is 4. Lithium, 7. Beryllium, its atomic mass is 9. And these are atomic numbers. Just remember, these are atomic numbers. Then we have boron, which is represented by B. As you can see here, they start with B. So its symbol is Be and boron symbol is B. And its mass number is, atomic mass is 11. Now come to carbon. Symbol is C, atomic number 6 and atomic mass is 12. Now then 7 is the atomic number of nitrogen, symbol N and atomic mass is 14. Oxygen, atomic number 8, symbol is O and atomic mass is 16. Fluorine, atomic number is 9, symbol F and atomic mass is 19. Neon, atomic number 10, symbol Ne. Nitrogen also starts with N. So that's why here we have taken the first two letters, and first letter is always capital, and atomic mass is 20. Now sodium, this name comes from its Latin name. Atomic number is 11 and its Latin name is natrium, and its symbol is Na, and atomic number is 23. Then magnesium, atomic number 12, symbol is Mg, and atomic mass is 24. Silicon, atomic number 14, symbol Si, and mass number is 28. Then phosphorus, atomic number 15, symbol P, atomic mass number 31. Then we have sulfur, atomic number 16, symbol S, atomic mass number 32. Chlorine, atomic number 17, symbol Cl, atomic mass number 35.5. Argon, atomic number 18, and symbol is Ar, and atomic mass number is 40. It is also an inert gas. Potassium, atomic number 19, and symbol is K, atomic mass number is 39. Calcium, atomic number 20, symbol Ca, atomic mass number is 40. And why we are calling these as inert gases and neon also? Because they are stable in nature, and how they are stable in nature that I'll discuss later. That's why we call them inert gases. They do not combine with any other element, and rest of the elements combines with another element or the same elements to be stable in nature. Then we have ions. Ions are the charged particles, or they are formed by positive charge or negative charge. But how these charges are attained, how these charges are produced. So when these elements, as I told you, these elements, when they want to be stable in nature, so they lose some electrons or gain some electrons from them. So when they are losing or gaining, depending on this, they attain these ions on them. And as a result, we call them cations and anions. Let's take an example of sodium. Sodium, its atomic number is 11, and its electronic configuration is 281. To get exist, if any element wants to be stable in nature, its outermost shell has 2 electrons or 8 electrons, but here 1 is present, so it can lose 1 electron from it. So if this sodium loses 1 electron, it becomes 2,8, and now it becomes stable in nature. And where this 1 electron is going, this one, it transfers this electron to another sodium or some other element to be stable in nature. And if it loses 1 electron, it attains positive charge, and it loses 2 electrons, it attains 2 positive charges. And if we talk about case of chlorine, its atomic number is 17, and its electronic configuration is 287. And if this chlorine wants to be stable in nature, it will take 1 electron. Although it can lose 7 electrons also, but it needs tremendous amount of energy. So it is easy to take 1 electron, to gain 1 electron. So when any element gaining electron, it has negative charge on it, and it becomes an ion. So this is how these ions or charged particles are formed. So this is how these charged particles and these ions are formed. So I hope till here it is clear to everyone how these charged particles are formed, how ions are formed in nature. This is due to the losing of electrons or gaining of electrons. So I hope till here it is clear to everyone how these charged particles are formed. We can take any other example like aluminium. Its atomic number is 13. So 283, its electronic configuration is 3. So to be stable in nature, it loses 3 electrons. And if it is losing, it is giving electrons. So it has positive charge on it. And here it is losing 3 electrons, so it becomes 3 plus. So this is how electrons are. We can take